Hi there. I had a request for a video on this 11.1a. So as we get started in Chapter 11 on rational expressions, they begin with a lesson just defining that. And what it means really is when you're looking at rational expressions, which will always be fractions, because that's what makes it rational, and you're going to have variables in your denominators. So here you can see there's an x in our denominators. So one of the issues we have when you have fractions is that you want to make sure that you never divide by 0, because that's undefined. So we always have to be aware of making sure that your denominator does not end up 0. So where we're headed in this chapter is eventually we're going to be solving, and you're going to be finding values of x that solve an equation. And we'll have to be sure that as we solve, that whatever we get for an answer doesn't actually end up making this denominator make this denominator 0. If that happens, we're going to have issues with our solution. So, as we get started, we're just looking at what can x not be? What's going to be a problem? And so sometimes when you look at these, you can just glance at it and tell what's going to make the denominator 0, but sometimes you can't really. Maybe you're not as good with that mental math. And so this one, basically what we'll do on these, and if you can do it in your head, great. If you can't, well, let's just set it up. We want to make sure that 5x plus 1 does not equal 0. And then you really just solve it like a regular equation. Let's subtract the 1. So 5x cannot be negative 1. Divide by 5. So then I want to make sure that x does not ever end up equaling negative 1/5, because that is going to be what makes this denominator 0. If I plug in a negative 1/5 times a 5, that's a negative 1 plus 1, that's 0. That'd be bad. Okay, now notice I'm done with that. That's all they want. I don't care anything at all about the numerator. I don't care what, it could be 0, that's fine, no big deal. We ignore that. We're only working on the denominators here. So let's just do a couple. So on this next example, okay, actually it might be worth trying it in your head. Can you figure out what x would need to be there to make that be a 0? Okay, let's check it. 3x minus 3 cannot be 0. So you add the 3 to the other side, and then you divide both sides by 3. So when you divide by that 3, 3 over 3 is just 1. So x cannot be 1. Is that what you guessed it to be? Okay, let's try one that's a little bit harder. This denominator is actually a quadratic. We've got an x squared in there. And so what you want to do with this, when you have a quadratic, typically you're going to have two things then that maybe will create a problem. And so what we always want to do is look at this quadratic and factor it. Okay, so if you factor that thing, that factors down x and x. You're going to want a 3 and a 4. Looks like it'll be a minus 4 and a positive 3. Okay, so I want to make sure that this x minus 4 does not end up being 0, because then I'd have 0 times something, and that'd be 0. And I'd want to make sure that this x plus 3 does not end up being 0, because then I'd have 0 times something, and that would get 0. So this would be one of those ones that maybe you can just look at it and do it in your head. What value of x is going to make this be 0? And you should be thinking, oh, that'd be a 4, so x can't be 4. And then you'd look at this one and say, well, what value of x is going to make that thing be 0? And you'd say, well, x can't be negative 3. Okay, it's easier to see it when it's in this factored form. We can try one of these. Let's plug a 4 back in right here. That'd be 16. Minus 4, that'd be 12. Minus 12 is 0. So you can check those and make sure that that's what happens. But if you put it in factored form, it's pretty easy to see then what your restrictions are going to be. Okay, let's try one more. Again, it's a quadratic because of the x squared, so that implies I should try to factor it. On this one, it looks like I'm just going to pull out a GCF. I could pull out a 3x, and then I have a 3x minus 1 left. Okay, so what that means is I don't want this to be 0, and I don't want this to be 0. So if you can do it in your head, great. If you can't, you just set it up and say 3x cannot be 0. Divide by 3. All right, x cannot be 0. That's one of my answers. Then I do it with the other quantity. 3x minus 1 cannot be 0. Add the 1 to the other side and divide by 3. So x cannot be 1/3. And those are the two restrictions. All right, so that's all you're doing in 11.1a. Good luck.